Hello, welcome to this video on small angle approximation. I'm just going to start by referring to the formula, or the formulae. There's the three formulae we're using. These only work when theta is small and in radians. You can see we've got degrees there just for reference really. So you can see there up to about 0.5 radians. They're pretty close there, aren't they? So that's nearly 30 degrees. And then they start, sine and tan, start to wave off a bit. So we're just showing sine and tan there, just as an example really. But what you need to be able to do is use these formulae. Let's look at an example here. This is from the Pearson textbook. So we've got sine 2 theta. That's going to be about 2 theta, because sine theta is about theta. So sine 2 theta is about theta. Plus till tan theta, that's going to be about theta, all over 2 theta. So starting you off with a nice simple one. 3 theta over 2 theta. Thetas cancel out. So you've got an approximation there of 3 over 2. There you go. 3 over 2. So that's just a nice one to introduce the concept of replacing these sine and tan terms with something in terms of theta. Okay, let's move on to this next one. Just introducing using cos. Well, cos theta is approximately 1 minus a half of theta squared, or sometimes you see this as theta squared over 2. Let's have a look at how we deal with this. So this is going to be approximately 1 minus a half of 4 theta, not theta, but 4 theta squared. So there's the cos 4 theta bit. Then we minus 1 at the end. All over, well, theta, sine 2 theta is just going to be 2 theta. Just put that in brackets so we can kind of see we're multiplying. So what's happening at the top? We've got 1 minus 4 theta squared is 16 theta squared. But remember, that's all over 2. We're taking half of that. Minus 1 over 2 theta squared. Well, we can tidy this up a bit. Those ones cancel out. The theta squareds cancel out. So I've got 16 over 2, which is 8, over 2, which is 4. Here's an OCR exam question to have a look at. So the left-hand side, which is 1 plus cos theta minus 3 cos squared theta, is roughly going to be negative 1 plus 5 halves of theta squared. We're going to have to show that. Again, it's a case of substituting and simplifying. So using our little rules, our formulae, approximation, left-hand side is approximately 1 plus 1 minus a half theta squared minus 3 lots of, this is going to be cos squared, so I'm going to have 1 minus a half theta squared all squared. So let's have a look. What do? We're going to square that bracket first. Get this nicely squared. So 1 times 1. I've got two lots of negative a half theta squared, so that's a whole 1 theta squared. Negative a half theta squared multiplied by negative a half theta squared. That's going to give me a quarter theta to the power 4. And we have 3 lots of that, so let's write it all out. Minus 3 plus 3 theta squared minus 3/4 theta to the power 4. What it doesn't say in the question, and it should do really, is anything theta cubed or above, powers of cubed and above, we tend to be able to cancel because, or just get rid of, because they're so small. Small angle, small value in radians, high powers just become very, very small, so we can get rid of them. So let's just put all this together. What is it going to be? 1 add 1 minus 3 is negative 1, of course. You've got the negative a half theta squared plus 3 theta squared, that's 2.5. Or as it wants in the question in fraction form, 5 over 2 theta squared as required. So we're focusing on substituting using these and then simplifying. Okay, here's the final example. It's a practice paper question from OCR that I found. I thought it was an interesting one to have a look at. So let's rewrite this equation here. So cos half theta, well, that's going to be at the top of the fraction. The numerator is going to be 1 minus a half lots of a half theta in that bracket squared. So I've just, instead of, I've replaced theta in here with half theta. That's all going to be 1 plus sine theta, well, 1 plus theta. And that's going to equal 0.825. Okay, so I'll have 1 minus an eighth theta squared over 1 plus theta equals 0.825. So yeah, half theta squared, all squared would be a quarter theta squared, and I half that, so I've got an eighth of that. Well, what do we do here? We need to have a bit of a play with this. So I multiply through by 1 plus theta. So I've got 1 minus, well, we're going to go into decimals now. So an eighth would be 0.125 theta squared equals 0.825 plus 0.825 theta. I've just multiplied through by 1 plus theta. And then I rearrange this. So I've got something with a positive lot of theta squared. So I'd have 0 equals 0.125 lots of theta squared plus 0.825 lots of theta. And then I've moved over the 1, so 0.825, so that's going to be minus 0.175. So we've got a quadratic equation. Just clear that's a 0 there, that all equals 0, so I can solve that in any way you want. use a formula or whatever, or just use your calculator in this instance. And you get theta, you get two solutions there, to 3 significant figures, 0.206 or 0.206, and theta equals negative 6.81. Well, what do we think? We've got to disregard one of these, negative 6.81. That's way too big to be dealing with in small angle approximation. So I don't want this one. It's too big, isn't it? It's too big. So we just have this solution here in this instance. Okay, we'll go through some examples. I hope they're all clear. Thank you very much.